Well, hello students, welcome back to mathematics class with me, Mr. Alfie. In this video, we're still going to learn about factors. Let's check this video out. Scalar multiplication. When a factor a is multiplied by constant k, the operation is called scalar multiplication. The product ka is called a scalar multiple of a and is defined as follows. For k greater than 0, that means k is positive. Ka is a factor with magnitude k multiple with magnitude a and the same direction as a. For k less than 0, the ka the opposite direction of a, as you can see here. For k equal to 0, ka is a 0 factor. If a multiple with positive numbers, so they are the same direction. If a multiple with negative numbers, they are in the opposite direction. So, for any factor a and ka are parallel factors if the scalar k is not equal to 0. That means whether the scalar is positive or negative, the product always parallel to factor a. As you can see here, they are parallel. Further, the scalar multiple of a column factor xy can be found by scalar multiplication of its component. So if k multiple with the factor xy, you simply multiply k with x component, so kx, and k with y component is ky, where k is a scalar. And if u and v are factors, and m and n are real numbers, then m plus n multiple with factor u equal to m multiple with factor u plus n multiple with factor u, and m multiple with factor u plus factor v, you simply multiply m with u and m with v. Let's jump to the example. It is given that p is 3, negative 6, q, negative 2 and 5, and r, m and 4. If the factors p and r are parallel, find the value of m. Okay, p and r are parallel. That means there is a scalar multiplication between p and r. Then p equal to kn for some constant k. So what's p? P is 3, negative 6 equal to k times r. R is m and 4 from here. So 3 negative 6 equal to k times m, km, k times 4, 4k. And then we find two equations, 3 equal to km and negative 6 equal to 4k. From the second equation, we find the value of k equal to negative 3 per 2. And then substitute the value of k equal to negative 3 per 2 into first equation. 3 equal to km. That means 3 equal to negative 3 per 2, that's the value of k, times m. And the value of m equal to negative 2. This is how to solve this kind of question. Next example. Let's factor a is 3, 1, factor b 2 and 1, negative 1, and c 5 and 5. If c equal to ma plus nb, where m and n are scalars, find the values of m and n. Okay, c equal to ma plus nb. What c? C is 5 and 5, a is 3 and 1, and b 2 and negative 1. You simply multiply m with these factors and n with these factors. You'll find that 3m m plus 2n negative n. And then you'll find that factor 5 equal to 3m plus 2n, m minus n. Okay. Now we have found two equations. The first equation is 5 equal to 3m plus 2n, and the second equation is 5 equal to m minus n. Either you're going to find the value of m and n by elimination or substitution. You'll find that the value of m equal to 3 and the value of n equal to negative 2. ABCD is a parallelogram. Express each of the following as a single factors. AB plus BD plus DC. This is factor AB, this is factor BD, and this is factor DC. As you can see here, the terminal point of the first factor meets the initial point at the second factors in this point. And then the terminal point at the second factors meet the initial point at the third factor in this point. So this is so simple because the terminal point meet the initial point. You can simply find the factor resultant as factor AC. Next, for B, DC plus BC plus CA. This is factor DC, this is factor BC, and this is factor CA. We can't just find the factor resultant because in this point, the terminal point meets another terminal point. Okay, so how to solve this? In this, we can write this as DC plus AD plus CA. We replace BC with AD because factor BC equal with factor AD. They have the same magnitude and the same direction. DC plus AD plus CA. We can write it down as DC plus CA plus AD. We move factor CA to the middle and factor AD to the back. So in this, the terminal point of the first factor meet the initial point at the second factor in this point, and the terminal point at the second factor meet the initial point of the third factor in this point. So the factor resultant is from factor D to factor D. Start from factor D to here, to here, to here, and end at factor D. So the factor resultant as a single factor is factor DD or equal to factor 0. And then C, factor AB minus a half of factor DB. It is equal to factor AB plus a half of BD. Because we multiple negative to factor DB, it becomes factor BD. We switch the terminal point and initial point. So it's equal to BD. This is factor AB, and then this is factor BD. Now we're going to identify factor of negative BD. Negative of BD, it is BE or factor ED. We're going to choose one. Let's choose factor BE. So it is AB plus factor BE. So you can see here the terminal point at the first factor meets the initial point at the second factor in this point. So we can determine the factor resultant equal to factor AE from A to E. Next example. In the diagram, T is a point inside triangle ABC. TA equal to A, TB equal to B, and TC equal to C. Express factor BC, CA, and AB in terms of A, B, and C. Let's do one at a time. Let's do factor BC first. This is factor BC. See factor BC as a factor resultant. Factor BC is a factor resultant of factor BT plus factor TC. So we can write it as this one, BT plus TC. Factor BT is equal to factor negative B because B equal to TB. If BT is negative of B, as you can see here, B in this direction and then BT in this direction. So the opposite direction. And factor TC equal to factor C. So BC equal to negative B plus C. Next, factor CA. This is factor CA. See factor CA as a factor resultant. Factor CA is a factor resultant of factor CT and factor TA. We can write factor CA as factor CT plus factor TA. We know that CT equal to negative C because C equal to TC, and TA equal to factor A. So CA equal to negative C plus A. And factor AB, this is factor AB. See factor AB as a factor resultant. Factor AB is a factor resultant of factor AT and factor TB. We can write factor AB as AT plus TB. AT equal to negative A because A equal to TA and TB equal to factor B. So AB equal to negative A plus B. And then for B, Express BC plus CA plus AB as a single factor. Okay, this is factor BC, this is factor CA, and this is factor AB. As you can see here, the terminal point at the first factor meets the initial point at the second factor, and also the terminal point at the second factor meets the initial point of the third factor. So the factor resultant is factor BB. Start from B to here, to here, to here. Start from B and at B. So the factor resultant is factor BB, or zero factor. Or we can write it as BC plus CA plus AB. We have found factor BC equal to negative B plus C, factor CA equal to negative C plus A, and then factor AB equal to negative A plus B. And then we find that the factor resultant equal to factor 0.